This is TechSNAP, episode 385. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. This is episode 385, and it was recorded on September 27th, 2018. My name is Chris, and joining me every single week is my co-presenter, the admin, the technician, and now the podcaster full-time. Hello, Mr. Payne, Mr. Wes Payne.
Well, hello, Chris. And, it hasn't been every single week. You have been healing up. I'm just going to say I'm pretty excited to be sitting here next to you recording a TechSNAP again.
It's great to be back, and I'm coming back for a great episode in a little bit. After we do our warm-ups, we're going to dive into Kubernetes, and don't worry, if you're completely new or if you're an advanced user, trust me, we're going to have something for you. We'll be bringing on an expert and be chatting about the top 3 things you need to understand about Kubernetes, and then get into some of the advanced architecture questions that have been on our minds. But before we get into that, let's do those warm-up stories, including this announcement about something new being contributed to the community.
It's called HASSH, and it's a new open source project from Salesforce engineering. There's a long history of looking for signals in the IT field, right? There's all kinds of boxes you can put on your network to try to detect things that shouldn't be happening. But in all of those tools, there hasn't really been a great solution for SSH until now.
HASSH is really a network fingerprinting standard invented with the detection cloud team at Salesforce. It can be used to help identify specific client and server SSH implementations. These fingerprints can be easily stored, searched, and shared in the form of a standard string of summary text.
Some of the use cases you might have if you're going to use HASSH, well, it can be deployed in a highly controlled and well-understood environment, somewhere where you have a known list of all the fingerprints that you want to allow. You know what clients your employees or customers use. HASSH can immediately point out when some other, maybe malicious client is attempting to connect.
That seems obviously useful.
Another example is it should be possible to detect, control, and investigate brute force or credential stuffing password attempts at a higher level of granularity. Most of the time, these days, you just have, what IP is it coming from? A lot of times these bots are behind a NAT or some other complicated network device.
Yeah, that's clearly useful in the case of a botnet attack. So think about it like this. HASSH will be a feature of the specific client software implementation being used. Even if the IP is NATed, such that it's shared by many other SSH clients, you're good.
Yeah, it really adds another piece of data you can use to try to judge if a connection is malicious. Another thing I found interesting about HASSH is there was a previous sort of known exfiltration technique using an SSH message KX init packet, which is kind of an obscure packet that happens as an SSH connection is getting set up. Because it's not yet a complete connection, there's no real logs, and a lot of current packet analyzers don't have any solutions for this. HASSH does.
Right, and think about it like this. It can work in approach with other tools, so it really could augment other contextual indicators. Like if you have a network intrusion system on your network, it isn't necessarily a replacement, it's an augmentation. And the reason why it really has our attention here is because this week Salesforce announced that they're going to just open source this thing.
Now, how does it actually work? Well, basically it produces fingerprints, MD5 hashes to be precise, that are constructed from the specific selected set of algorithms that are supported and preferred by various SSH applications, whether that's a client or a server. These algorithms get exchanged when you're doing, right after the initial TCP three-way handshake. You then set up, all right, what version of SSH are we going to talk about? What parts of the protocol do you support?
This negotiation that Wes is talking about, it forms an integral and required component of the entire setup, so that way you can keep track of the final encrypted SSH channels.
And now this is not some sort of magical technique. It basically just turns out that the existence and ordering of the algorithms that are exchanged vary a lot and are pretty unique by client. So even applications that are different but share some of the same libraries will often have very similar or the same hash values.
Can I ask you a point of clarification, though? You said that they're using MD5. Why not use something bigger and better like SHA-256?
That's a great question, and the team at Salesforce actually wrestled with this, and they were using SHA-256 for a while. But, it's just a longer hash, and they found that it was harder to get good heuristics on. When you're looking at a bunch of these hashes and trying to quickly compare them as a human, it was more difficult.
And I suppose the point of it really isn't to secure data, it's to securely identify something.
Yeah, basically, they're hoping that the risks of any collisions aren't super relevant and are less of a concern in this space, and that it's better to have a more manageable hash size.
You'd really have to be operating at a massive scale to worry about collisions, but I suppose it's possible, especially on a botnet attack. It could be possible.
Go check out the show notes if you want to learn more about how you might make use of hash. I do want to stress it's not a silver bullet. It's really just another interesting piece of information, a good heuristic that might help you secure your servers.
Some more news this week in the warm-up. Cloudflare is announcing an experimental deployment of a new web privacy technology that's called ESNI. All right, help me understand this, Wes, because I'm familiar with SNI, which is server name indication. What is ESNI?
Well, it's encrypted SNI. Now, server name indication is used when you want to host multiple HTTPS sites on one server, right? Because you're going to need to get the certificate that matches the server that you're actually trying to talk to. SNI, you hand over a plain text name of the server you're actually trying to talk to, and then you get your content. But that can be a pretty big information leak.
Yeah, this is sort of the negative side of HTTPS is this initial request comes across in clear text.
Right. Now, of course, with HTTPS, they can't see the rest of that transaction. But if you're a sneaky ISP trying to aggregate data and sell it on a secondary market, well, I don't want that.
And so what's new this week is Cloudflare has proposed a technical standard for encrypted SNI, or like Wes said, ESNI, which would hide the identities of the sites you visit.
Yeah. It's also, I would like to point out here, people have mixed feelings about Cloudflare, but this is proposed as an open standard. The development's being done in the open, so it looks like a good thing. And if you think about it, well, of course, Cloudflare is going to get to see the decrypted SNI even with this new solution. They already had that information. So this strictly decreases available information, so it's a win for privacy. Unfortunately, you're not going to be able to play with it anytime soon. If you do run a test version of the Firefox browser and connect to a Cloudflare site that's using this new technology, then you can play with it a little bit, but it's early days. We probably won't see this anywhere anytime soon.
Now, our last warm-up story isn't news yet, but it should be any day now. A new release of everyone's favorite orchestration tool, Kubernetes, which is coming out with some freshly baked goodies. The one that caught my attention is pod vertical scaling. I love the name, and I love the functionality.
Yeah, I've also seen this referred to as right-sizing because it's an infrastructure service that automatically sets resource requirements of pods and then dynamically adjusts those in real time based on things like historical resource utilization, the amount of resources available on that node right now, and other events that you might care about like out of memory.
And just for newbies out there, just to define a pod real quick, think of pods as the smallest deployable unit of computing that could be created or managed in Kubernetes.
Right. So instead of deploying a container, you deploy a pod. And that might have one container or it might have several, right? So you might have your web app, but then you also have an Nginx container running in that same pod being a reverse proxy for it.
Now, if some of this Kubernetes stuff is making your eyes glaze over right now, don't worry. Will Boyd's going to join us in a moment, and he's going to help explain a lot of this to us. But I bet there's a couple other things that caught your attention in the release notes.
Yeah, one of them is the new resource quota API. Now, it's in beta in this release, so still it's not stable yet. But if you have a Kubernetes cluster that you're allowing multiple teams, maybe diverse teams to work on, this could be a good feature for you because the quota system will identify specific resources that should be limited by default. With current behavior, resource consumption is unlimited if a quota doesn't exist. So you can already make quotas for things, which is nice, but if some administrator hasn't taken the time to do that, well, then a team that's not paying too much attention could eat up all of those resources. Now there's going to be a smart system to sort of set some default limits for you automatically. Now, of course, there's tons of other features. If you're interested, of course, just, go to the show notes, techsnap.system/385. But one other little highlight I noticed is SCTP support for services, pods, and endpoints. What's SCTP? Well, of course, it's the Stream Control Transmission Protocol, a fascinating protocol that really deserves a place up there with TCP and UDP. Hasn't seen a lot of deployment, but Kubernetes has support now.
All right, enough dancing around it. Let's bring on our Kubernetes expert. So joining us now is Will Boyd. He is a training architect at Linux Academy, and he has just completed the final touches on his new course called Kubernetes the Hard Way. And so we wanted to bring Will on to the show and chat a bit about Kubernetes and some of the larger concepts and some of the small nitty details. So, Will, welcome to TechSNAP.
Thank you. Thanks for having me.
So, Will, let's start with just to help people who are not super familiar with Kubernetes. Right off the top of your head, if you could, what would you say are like the top 3 things or concepts people should understand about Kubernetes?
Well, Kubernetes is an orchestration tool. So I suppose the top 3 concepts would probably be like containers, orchestration, and that's pretty much it, honestly. Just those 2. Maybe some other things like self-healing and auto-scaling.
Oh, yeah. Where do you think it fits? When do you go from I'm happy just running some Docker containers on a single VM somewhere to I really need something like Kubernetes?
There's a lot of different answers to that question. I think one of the answers to that question has to do with the number of containers you're managing. If you're managing more than about 4 or 5 containers, you could probably find Kubernetes to be quite useful. If you have more than one VM or more than one physical machine that you're running containers on, Kubernetes can be great. Also, if your environment is dynamic and frequently changing, for example, if you're adding and removing hardware nodes on any kind of semi-frequent basis, then Kubernetes is going to be really useful in those situations.
Yeah, that's a great way to look at it. So you just did the hard way, which is a great title to begin with, but it involves a more advanced setup. It kind of assumes you've got some Kubernetes background, some basics about the Linux command line. I went through the course myself, and what I liked is it's really the first time I've been able to wrap my head around a multi-controller setup, multiple etcd servers, and a load balancer sitting in front of all of that. When does that become the scenario you have to go with? That's the architecture you need to deploy. What scale do you see that?
That really has to do with high availability. So if you're in a production situation where you're in a business and the business is demanding basically as little downtime as possible, and any downtime is a major thing, and you can't take your Kubernetes master down for an upgrade for 30 minutes in the middle of the night, and you'd much rather have that transition be completely seamless with no downtime, that's when you need to start looking at that high availability, multi-instance type of architecture.
Okay, yeah, that makes a lot of sense. Sort of related, what sort of workloads do you find work especially well with Kubernetes? Or maybe what workloads should you avoid right now?
I would say microservices, any kind of microservice architecture, I think works really well with Kubernetes. And that could also include not necessarily, really deep webs of microservices, but just really small kind of one-off services. So if you have small little workloads and you need a lot of them, and you need to make sure that they're really highly available, and you don't want to spend a lot of time paying attention to each one and doing all that orchestration manually, that's going to work really well in Kubernetes. I think really big monolithic applications probably are not going to work quite as well. Not to say that you can't use Kubernetes in that scenario, but it's going to be a little bit harder to get all the benefit out of it if you have a really big monolithic application.
Now, I want to get more into the advanced stuff. That's sort of the high-level conceptual things, but maybe we could segue a little bit into your background. How did you end up putting together Kubernetes courses and things like that?
So I actually started my IT career in QA. That was just for a little while. But the majority of that career was spent being a software developer. And then I transitioned sort of into a DevOps role. And in my time as a developer, I got really excited about this concept of microservices and the concept of automated deployments and continuous delivery, all the things that, are kind of part and parcel of DevOps. And Kubernetes was just one of those things from the operational side that I found to be very, very useful and very, very exciting. It seemed like something that would solve a lot of the problems that I was facing in the day-to-day. And so that's kind of what initially got me excited about it and start learning it.
Has that lived up? One thing I've seen has been that in deployments I've seen, a big selling point of Kubernetes is that interface for developers. Like, yes, there are operational wins that you can get with Kubernetes as well, but you have a nice story, a nice API that developers can use to get just as much control as they want, but not have to go manage actual servers anymore.
Yeah, it's definitely hugely useful for developers. And Kubernetes is just one of those tools that has DevOps written all over it. And what I mean by that is that it really seems to be built on a philosophy that fully embraces dev and fully embraces ops. And as a result of that, I think that at the end of the day, it's something that developers can understand. It's something that they can interact with. It works in their world. They understand APIs. They understand how to work with those kind of things. And I think Kubernetes is one of those tools that just really does a good job of bridging that gap and including both of those perspectives in just from the ground up in terms of how it's architected.
Yeah, you've just put into words exactly what I've been feeling for a long time. So I love that. Now, okay, let's talk about some of the more advanced setups. So I mentioned earlier like a multi-controller setup. Something that I didn't really understand before your course is, and I suppose this is fairly true for Kubernetes in general, but when you set up a couple of controllers, I don't know, perhaps you could tell me, always or generally need to put a API load balancer in front of those controllers so that way you're not just hammering one of them. What is that load balancer's role and what actually makes it tick?
The role of that load balancer is really just to provide high availability for the Kubernetes API. So if I have multiple control nodes and I need to take one of them offline for maintenance or upgrades, or one of them just fails, I want to be able to interact with the cluster and not necessarily have to manually switch over to a different node that happens to be available at that time. So the load balancer basically handles that. By going through the load balancer, I'm balancing traffic across the nodes. That particular part of it really isn't all that important because generally it's not like you're going to be hitting your Kubernetes controllers with a whole lot of load unless you have some really sophisticated automation going on in a really big cluster. But the major component of that is just that high availability. So I'm interacting with a single point of contact for the Kubernetes node. Now in the Kubernetes, the hard way course, we do that load balancer in a very simplistic way, which is perfectly fine for that purpose. We just set up a simple Nginx server that balances traffic across all the Kubernetes nodes. In a cloud environment, of course, you can do all kinds of different things with your built-in cloud load balancers. You can use HA proxy. Really, you can use anything that's capable of balancing traffic to a variety of nodes on a particular endpoint.
Isn't that, in a way, sort of the best part, and for me, the most confusing part about Kubernetes is you can interchange some of these parts. So in a setup, you could be using Containerd, or you could be using Docker, or LXD, like it's interchangeable. A load balancer could be HA proxy or it can be Nginx. That seems like both a great thing and a way to just introduce a ton of complexity. What are your thoughts?
Yeah, that's absolutely true. And if you want to see, in my opinion, what is the absolute case in point for that, just look up how you implement networking in Kubernetes. In the documentation, you'll basically just find an extremely long list of different networking implementations. And I think that really holds true from that standpoint. There's all these different parts and pieces that are interchangeable, and that's definitely great. It means that anyone can adapt Kubernetes for their environment. They can build the plugins and they can build the implementations of some of these components that will allow you to make it very, very flexible. On the other hand, I think that yes, it can make it very confusing, particularly for new users. And I think the answer to that, and I think Kubernetes has made some good strides in providing an answer to that in the form of tools like Minikube and KubeADM that kind of take a little bit of the guesswork out of that equation, that give you kind of a ready-made sort of standardized setup to get you started and potentially also to use in production.
Okay, so this is based off Kelsey Hightower's pretty famous Kubernetes the Hard Way guide. When you've been going through this, what was actually the hardest part?
Definitely, I would say the hardest part was the networking and specifically adapting that for our platform. Because if you look at the Kubernetes the Hard Way guide, it's very much focused on Google Cloud Platform. And he just handles the networking by creating some network rules in the GCP space. And since our platform's not built on GCP, we could not do it that way. So we basically had to figure out our own way of doing that. And I was able to use WeaveNet to do that in a fairly simplistic way, but that was probably the thing I spent the most time on.
Of course. Yeah, because he went from an easy button to having to set it up. In fact, that's one of the points of the course really is there are installation scripts out there that could do the bulk of the setup for you, but part of the hard way is actually going through and just setting a lot of it up from scratch, which I think is the best way to learn.
Yeah, and that's really the purpose of it. I don't know that you really ever want to do it the hard way in production. Certainly you can if you have the knowledge to do that. And hopefully this course can give you the knowledge to do that. there's no reason not to use those kind of automated scripts and pre-built installers in the real world. But for example, just go to the GitHub issues page for Kube ADM, which is one of those tools, and you'll find tons of people that are seeing error messages that they don't really understand, and a lot of responses from some of the developers of Kube ADM that do understand those error messages. And that's just evidence, I think, that there's a lot of people that are struggling because they are using those tools, but they don't understand the internals. And I think it can be very helpful to understand those internals. And I think that's exactly what Kubernetes the hard way does, is it gives you a deeper understanding. So when you are using a tool like Kube ADM or Minikube or any of the other automated installers or scripts that you can find, when you run into problems, you're not wasting as much time because you know what the error message means, you know what the components are, and it just gives you that extra boost to help you troubleshoot and manage that cluster more effectively.
That's brilliant. And, we didn't like set this up to be like a plug for the course or anything like that, because it's not actually even available yet, is it?
No, it's not.
Yeah, see, if we were good strategic, like marketing experts, we'd do it like right before the day it comes out or something. Maybe we'll mention again so that way people know. So they'll have to keep an eye out. But I'll put a link to the things I can, which is some of the tools you've mentioned in the show notes, so people can go over to our website if they want to grab those. It's TechSNAP.system/385. And then we'll try to put it in a follow-up in a future episode when your course does come out for people to go get. I suppose in the meantime, they could go start with one of the basics and learn the fundamentals and then be ready for when Kubernetes the hard way comes out. Will, thanks so much for coming on the show and sharing your insights with us. I gained a lot out of this chat. It really helped clarify a few things for me.
Thank you.
And that brings us to the end of this week's program. Thank you so much for joining us on the TechSNAP show. Thank you to Will Boyd for joining us as well. Great chat there.
Just one more thought before we get out of here. I wanted to throw some love at Clonezilla. It's maybe not the shiniest or newest tool out there, but it's always there whenever I need it. I was just trying to back up this new laptop situation that we've got going on, Chris. Trying to get everything, I like to take an image right before I screw everything up. Of course, right? I mean, this is TechSNAP. You got to have backups.
And you could use something like DD.
Of course. I've used DD all the time. Yeah. But for some systems, it's just nice to not think about it. I boot up into a USB drive, install Clonezilla, go through their little terminal GUI, and away I go. Plus, they've got built-in SSH/FS support. So I just mounted another computer on my network, plugged them in over Ethernet, backed up a whole terabyte Windows installation, 15 gigs. It also has, checksum support, tests to make sure that your backup's going to restore correctly. Love it.
Me too. Used it for years. Just a huge fan of Clonezilla. Clonezilla.org if you want to check it out. Of course, we'll have it linked up to TechSNAP.systems. We'd love to get your emails, questions, war stories, thoughts about server orchestration, and all of it. TechSNAP.systems/contact.
Thank you for joining us for today's TechSNAP program. We'll see you
next week.